Okay, sorry you had to open a second file for tonight, but I just wanted to make sure I didn't run out of time. Okay, so continuing on, this is still lesson 12.7, and this is the part of the lesson that is about solving logarithmic equations. I kind of like that we ended up having a break because I do want to emphasize to you the difference between this kind of problem, which you saw earlier. This is exponential in form, right? The x variable or the independent variable is in the exponent. That makes it an exponential equation. And here, even though I used logarithms to solve this problem, the problem itself was exponential. The independent variable is in the exponent. The rest of this lesson is about solving logarithmic equations. So the general idea is if you have a log on each side of the equation, same base, and they're equal, that all-powerful equal sign means, well, these already match, so the rest of it has to match. So x has to equal y. So here, if you had the base 3 log of 9 is equal to the base 3 log of x, well, this x has to be equal to that 9. Those arguments are equal. So I need to get it to the form where I have log of something equals log of something. That is my goal, and once I get it to that format, it's easy peasy. So question 1, same base log, all-powerful equal sign means x plus 2 has to equal 3, and so x has to be 1. That's all there is to that one, believe it or not. Here, base 4 log, all-powerful equal sign means that 2x plus 6, the argument on this side, has to equal 3x minus 2, the argument on the other side. Now this is one of those lovely balancing equations problems that we love so much from like 7th grade or so, okay? So x equals 8. All right, here, question 4 is pretty straightforward, but question 3 requires a little bit more work. Can you see why? It's because it's not in the form log of something equals log of something. Here, we could use a property. That property is the division property, right? Division and subtraction, that relationship. And over here, we're going to use the reverse of that down in front, you know, that exponent. Can come up and I'd have 5 to the second, which is 25. Now this is fantastic because now I do have the form that I was just discussing. Log of something equals log of something, okay? These logs have the same base, and I can say, well, this argument has to equal the argument on the other side, and therefore x is 100. Okay, in this one, we are ready to go. We have the same log on both sides. Log of something equals log of something else. So x plus 3 has to equal 8x plus 17. And we just solve that back like we did back in the day. You know, move the 8x, move the 3, divide. Okay, and we're good to go on that. Okay? We have 2 more problems to do. These problems are a different case. Okay, so here we say, when solving logarithmic equations, remember that you can switch from log form to exponential form. So this format is different from what we just did. In these problems, we had log of something equals sine log of something. In the problems that are coming up here, we don't have logs on both sides. We just have a log on one side. And what we want to do is switch it to exponential form. So for instance, right here, I would rewrite that as 3 to the 4th is x. And so then I would need to know that 3 to the 4th is 81. So x is 81. So if you have a single logarithm, oh my goodness, you need to switch to exponential form, okay? Or if you can get it to a single logarithm. So in this problem, the implied base here is 10. So 10 to the 4th equals 2x minus 1. This is 10 to the 4th. So I'd have to add 1 and divide by 2. So this is the ever popular number 5,000½ for x. Okay? The next problem, don't get confused with this and the one that we were doing recently that had 2 logs. Here, the logs are on the same side of the equal sign. They're here and here. Okay, so this is not log equals log. This is a situation where I want to use properties. I'm adding logs, so I multiply their arguments. And now, because I have a single log, I want to go to exponential form. The base here is 10. So 10 to the first equals this. And this part that I just circled is x squared minus 1. So I can say, well, this is the same as x squared equals 11. So x, I would normally say positive and negative radical 11, but when we're dealing with logarithms, we can't have log of a negative. It's not defined. And so for that reason, I need to think about my domain, right? The log function just looks like this. It's only defined on the right half of the coordinate plane. And so I would drop that negative solution. Because if I were to plug negative radical 11 in, say right here, that's going to end up being a negative number. And I can't have that. Okay? Oh, is that all I have? It is! By gosh! Okay, you're done. Please bring these notes to class. Please bring your book to class and listen to anything else that you need here before tomorrow to make sure you're prepared. Thanks a lot.